Good afternoon, everyone. In the last session, we have seen fuzzy in the fuzzy logic system. What is fuzzification? Fuzzification means the input to the fuzzy logic system is crisp input. The crisp input will be converted into the fuzzy. Then fuzzy need to be converted into the crisp again. At the starting of the fuzzy logic system, I have shown you that fuzzification will occur. So fuzzification process is nothing but converting the crisp values to the fuzzy values. So that's what we have seen in the last session. So in today's session we'll see the defuzzification. So defuzzification means converting the fuzzy values to the crisp value. So input output to the fuzzy logic system is in crisp. So we'll give the crisp value as input and we'll get the crisp value as output. In between or inside the fuzzy logic system, it will have the fuzzy values based on the rules or rule based system. It will convert the crisp to the fuzzy, then fuzzy need to be converted to the crisp again. So the converting of fuzzy values to the crisp value is nothing but defuzzification. So in the process of defuzzification, there are few methods. We'll see one by one. So the first defuzzification method is lambda-cutset method. So what is lambda-cutset method means? Let us assume A is one fuzzy set. Fuzzy set A need to be converted into the crisp set means the crisp set is denoted with A lambda, A subscript lambda. So here lambda value is varying between the 0 and 1, including with both 0 and 1. 0 is less than or equal to lambda is less than or equal to 1. So here fuzzy set is represented with simple alphabetical A, and if you are representing some subscript as lambda means that is A lambda. So what are the variabilities? That means fuzzy set if you mention with R means R subscript lambda will be the crisp set. Okay, the lambda will vary from 0 to 1 by including both 0 and 1. So here A lambda, that is nothing but crisp set A lambda is equal to x such that mu A of x is greater than or equal to lambda. So your x value should be belongs to the fuzzy set A mu A of x. That mu A of x is nothing but membership value. Mu A of x is nothing but fuzzy membership value. If that fuzzy membership value is greater than or equal to the assumed lambda value, then that will become the crisp set. Okay, so we'll see with example for better understanding. So let us assume one fuzzy set A, that A is equal to x1 comma 02, x2 comma 03 and x3 comma x1 comma 0.2, x2 comma 0.4 and x3 comma 0.6. That means the fuzzy elements are x1, x2, x3. x1, x2 are the elements, fuzzy elements. The corresponding membership value, fuzzy membership values are x1 element corresponding membership value is 0.2, x2 membership value is 0.4, x3 element fuzzy membership value is 0.6. So here I have taken lambda is equal to 0.3. For lambda is equal to 0.3, how to convert that fuzzy set A into the crisp set? The defuzzification means, what is defuzzification? Defuzzification means we have to convert that fuzzy set to the crisp set, right? So capital A is simple capital A is nothing but fuzzy set. Fuzzy set is mentioned with x1 comma 0.2, x2 comma 0.4, x3 comma 0.6. That we need to convert to the crisp set. To convert that crisp set, what is the notation for crisp set? A lambda, right? Here lambda is taken as 0.3. That means A 0.3, A subscript 0.3 is equal to, What is the condition here? If your mu a of x is greater than or equal to lambda, that means membership value is greater than or equal to lambda, whatever we assumed, then that will become 1. Otherwise, it is equal to 0. Let us take that first. In the fuzzy set A, x1 for x1 element, 0.2 is the membership value. That 0.2 membership value is less than lambda, right? Your lambda is 0.3. It is less than lambda. Hence, in the crisp set A.3, that is crisp set, you will get x1 comma 0. Corresponding to the x2 element in the fuzzy set, x2 element corresponding membership value is 0.4. 0.4 is greater than the 0.3. Then the corresponding element or membership value in the crisp set is nothing but 1, x2 comma 1. Likewise, 0.6 is greater than 0.3. So x3 comma 1 you will get it in the crisp set. As x1 comma 0 means your elements will be on the x-axis, membership value is on the y-axis, right? Corresponding membership value on the y-axis is 0 for x1, right? So no need to consider that x1 also. That's why simply a.3 is equal to x2 comma x3 in the crisp set. So in a similar way, if we take another example, let us assume B as one fuzzy set. So B is equal to y1 comma 0.5, that is nothing but for y1 element the fuzzy membership value is 0.5, and y2 comma 0.4, y3 comma 0.7. So here again you need to compare that fuzzy membership values with the considered lambda. So here directly I have taken b.7. b.7 is nothing but, what is the lambda value here? Lambda is equal to 0.7. That means b.7 means lambda is equal to 0.7. b lambda, right? Here lambda is equal to 0.7. Corresponding to this 0.7, the fuzzy membership values which are greater than or less than, based on that you will get the either 1 or 0. So here 0.5 in the fuzzy membership value is less than the 0.7, right? That's why y1 comma 0 and y2 comma 0.4, right? In the fuzzy set 0.4 is also less than 0.7, that's why y2 comma 0 will get in the crisp set, and y3 comma 0.7 in the fuzzy set. So 0.7 is greater than or equal to 7, that is both are same, 0.7 and 0.7. That's why you will get y3 comma 1 in the crisp set. So finally your b.7 is equal to y3 you will get it, because y1 corresponding membership value is 0, that's why no need to consider that. y2 comma 0, that's why no need to consider that y2 also, only you will get y3. So in this way we can use the lambda cut method to convert the fuzzy set into the crisp set as a process of defuzzification. Okay, then we'll see the another method, or in the same method, that lambda cut method. So here fuzzy relation, simply here I have taken in another way of considering that fuzzy set. So here R is equal to, in matrices I have taken that fuzzy set. So this matrix form also you will get by cross producting the two fuzzy sets, you will get this matrix form, right? So here R is equal to, R is nothing but fuzzy set, simple R is nothing but fuzzy relation, and R lambda is nothing but crisp relation. If it is R lambda, R subscript lambda means that is crisp relation, only R means that is fuzzy relation. So here for capital R, which is nothing but fuzzy relation, is nothing but 0.3, 1, 0.4, 0.7. So here I have taken different lambdas. Lambda is equal to 1, lambda is equal to 0.5, lambda is equal to 0.2, and lambda is equal to 0. If it is R lambda, lambda can be replaced with 1, 0.5, 0.2 and 0. For that, what is the crisp relation? That we'll see. So first I am replacing that lambda with 1, then R1 you will get it, right? R1 is nothing but crisp relation corresponding to the fuzzy relation capital R what do you get the crisp relation in the R1, that we'll see. So your lambda need to be compared with the corresponding elements in the corresponding membership values in the fuzzy set. When you're comparing both of them, lambda with the corresponding membership value in the fuzzy set, your 1 is greater than 0.3. 1 is greater than 0.3, or with that value you have to consider, otherwise 0.3 is less than 1. So 0.3 is less than 1 means in the crisp set you will get that equal to 0, and 1 is equal to 1, you will get that again the same one, you will get it in the crisp set. 0.4 is less than 1, 0. 0.7 is less than 1, 0. So 3 elements are less than the assumed lambda, and only 1 is equal to that lambda. So because in the fuzzy set you have 1 means maximum membership value is nothing but 1, that means total it belongs to that fuzzy set. If it is 1 means, right? So the same thing will be happened in the crisp set also, that's why 1 again in the crisp set also the membership value is same. So likewise if you go for R.5, again you compare that membership values in the fuzzy set with the 0.5. 0.3 is less than 0.5, right? So it is equal to 0 in the place of 0.3 for the crisp set, and 1 is greater than 0.5, which will get 1. 0.4 is less than 0.5, you will get 0. 0.7 is greater than 0.5, you will get 1. Again another lambda, that is 0.2, or 0.2 is equal to, by comparing this lambda with the fuzzy set element or fuzzy membership values in the fuzzy set, so this 0.2 is less than the all membership values in the fuzzy set, that's why you'll get all ones in the R 0.2. So likewise R0 also, R0 means 0 is the lambda value, so that is obviously that is less than the membership values in the fuzzy set, so you'll get R0 is equal to unit matrix. Okay, so this is another defuzzification method. Here that method is called maxima methods. So in this maxima method, so there are 3 terms. One is first of maxima, so let us assume that first of maxima is FOM, last of maxima LOM, mean of maxima MOM. If you see that figure, your membership value is mentioned on the y-axis, mu of x, and your fuzzy elements have taken on the x-axis. Those are 2, 4, 6, 8, 10, 12. The membership value is 0.2, 0.4, 0.6, 0.8 up to 1. But maximum membership value for this figure is only 0.8. At 0.8 itself, it is reaching the maximum value. So how to find out that first of maxima, last of maxima, mean of maxima means? So let us assume that we are converting the fuzzy into the crisp, right? Your fuzzy is given in figure by representing the membership value as well as the corresponding elements. So that you need to convert into the crisp value, right? To convert that into the crisp value, so first of maxima, let us assume that x star represents the crisp value. X star means crisp value. So for first of maxima, the x star, that is nothing but crisp value for the first of maxima. If you want to find out the first of maxima, what is the maximum membership value from the given figure? It is 0.8. So 0.8 is the maximum membership value. It is not attaining the 1, right? Only 0.8 is the maximum membership value. Corresponding to that maximum membership value, what are the elements on the x-axis that we need to see? On the x-axis, the corresponding elements of that maximum membership value. So 0.8 membership value is attaining at an element at an element 4, and it is continuing till 8, right? 4 to 8 you are having maximum membership value. So that we need to consider, that portion we need to consider to find out this 3, that is nothing but first of maxima, last of maxima, and mean of maxima. To find out that what is first of maxima means where that maximum membership value is attaining, the corresponding element on the x-axis is nothing but first of maxima. It means at an element 4 your membership value is attaining the maximum, right? 0.8. That's why your first of maxima is nothing but 4. X star is equal to 4. X star is nothing but crisp value. So from that figure we have taken that crisp value. Last of maxima means where that maximum membership value is about to end. That is nothing but at 8, right? On the x-axis at 8 it is about to end. That's why your last of maxima is nothing but 8, and the mean of maxima is nothing but, to find out that mean of maxima we have to use this formula, that is nothing but x star is equal to summation xi belongs to m. So here what is m, that we'll see. Xi belongs to m and xi by mod m. So what is m? M is nothing but x, where mu a x is that mu a of x is equal to height of the fuzzy set. Your mu a of x is nothing but height of the fuzzy set. So corresponding to that height of the fuzzy set, the corresponding element x will consider the number of elements for that height of the fuzzy set. Height of the fuzzy set is we can find out that height of the fuzzy set by counting the values from first of maxima to last of maxima. How many values are there? What are the values? So 4, 6, 8 are the numbers, right? How many numbers? To find out that mod m here it represents the cardinality of set m. So m set is nothing but 4, 4, 6, 8 are the elements. To find out the mod m is equal to number of elements. Cardinality is nothing but number of elements in that set m, that is equal to 3. To find out that x star, simply you can follow that formula, or simply you can see here x star is equal to, so here mean of maxima, right? Mean of maxima means what are the elements on that maximum membership value. That means 4, 6, 8 are having the maximum membership values. The corresponding among the fuzzy elements, only 4, 6, 8 has maximum membership value. That's why your summation includes this 4 plus 6 plus 8, summation xi, right? Here xi is nothing but 4, 6, 8. And what is the cardinality of mod m? Means mod m is nothing but cardinality of the set m. Set m consists of only 3 elements. That's why your mod m is equal to 3. 4 plus 6 plus 8 by 3, which is equal to 6. Corresponding to that fuzzy figure, your crisp value is nothing but x star is equal to 6 in terms of mean of maxima. Okay, so by using these maximum methods you can find out the crisp values like this from the fuzzy set or fuzzy figure. So another method is weighted average method. Here also it is a little, so if you see that from the 3 methods, first method is little easy, second method is a little difficult, third method is a little more difficult. That's it. Weighted average method means here also to find out the crisp value, that is x star is equal to summation mu of x into x. It is nothing but membership summation of product of membership value into corresponding element. Product sum of the product of the numerator is nothing but sum of the product of the membership value and the element. Denominator is nothing but summation of the membership values. Mu of x is nothing but membership value, right? So by using this we can find out the crisp value. Let us take that figure. If you see the figure, your membership value is represented with mu of x on the y-axis. Corresponding elements have taken on the x-axis. So 60, 70, 80, 90, 100 are the elements. Corresponding membership value will vary from 0 to 1 only by including both 0 and 1. Your fuzzy membership value always it will be between the 0 to 1 by including both 0 and 1. To find out the x star by using the formula, so what we need to do, we need to find out the corresponding membership value and its element. At 60 element, what is the corresponding membership value? 0.6. So 60 into 0.6 plus summation, right? Sum of the product of the membership value and its element, plus 70 into corresponding membership value is 0.4, plus 80 into corresponding membership value is 0.2, plus 90 into corresponding membership value is 0.2 again, plus if you want you can add 100 element also. 100 into corresponding membership value is 0, so that is equal to 0 is divided by sum of the membership values. Sum of the membership values are 0.6, 0.4, 0.2, again 0.2, because corresponding to that elements we need to add the membership value. 60 corresponding membership value is 0.6, 70 corresponding membership value is 0.4. So in the denominator, 80 corresponding membership value is 0.2, again 90 corresponding membership value is 0.2. If you take 100 corresponding membership value is plus 0. So if you do the calculations, you will get x star is equal to 70. So that is a crisp value. So like this we can convert the fuzzy set into the crisp set. So by this we can get the complete fuzzy logic system. By giving the crisp value as an input, your fuzzification will done in the fuzzy logic system, so which will convert the fuzzy to the crisp. Again crisp will be converted to the crisp to the fuzzy, and fuzzy will be again converted to the crisp by using this defuzzification methods. Okay, so this is all about the fuzzy logic system and defuzzification methods, different defuzzification methods used in fuzzy logic system. Thank you all.